Yeah, there we go. Hydroxide. So when you talk about bases, I need you to know that a metal oxide will always form a hydroxide. It'll always form a base if we do a synthesis reaction between a metal oxide and water. Metal oxides and water react to form bases. How do we make acids? So metal oxides and water make acids. How do we make bases rather? How do we make acids? Yeah? Non-metal oxides and water. Good. So make sure if that's feeling uncomfortable to you that you back through that note. You can ask me for help with it. I did leave you with some homework for that. Did you have any questions from that? Questions from the homework that went with that you want to take up? We can do so now if you like. If not, we're going to get going on to today's stuff. Nobody had any questions?
I think we went over it the other day.
Yeah, we did a few examples in class the other day. That was good to get people going. All right. Cool, cool, cool. Then today we're going to start talking about single displacement reactions. Would some kind sweet soul hand these out for me? Thank you very much, Caitlin. I appreciate it. Yeah. Yeah, go ahead.
Oh, and my pen fell down. That's very good. I'm sweating. Yeah, I don't like my sweater. And the one for
Thank you very much.
That's not a thing. 842. H2O.
Okay, so we're going to talk today.
Just a reminder, grade 12 students, Dr. Rock is here, and they're in the library. If there are issues, please come down. Thank you.
Oh. Does that describe anyone here? No? Okay. So we're talking about single displacement reactions. What's a displacement reaction? Okay, I will do this. Put this in here. What's a displacement reaction? Oh, surely someone can tell me. Yeah? That's what? That's okay.
I know what it is.
That's okay. I seem to be the technology issues today really are making me feel a little crazy, but that's okay. So, single displacement reaction, it says right there on your note, is one where a compound and an element react. So let's pick a compound, a nice easy one. Give me an ionic compound. Sodium chloride, okay. And the formula, so we could say sodium chloride, which has what formula? NaCl. Very good. Yeah. You don't need to write this out yet. This doesn't need to fit into the note. This we're just reviewing just the grade 10 stuff here. So really quickly, so yeah, you don't even need to put this in your note. If I had sodium chloride and I reacted it with solid lithium, what's going to happen in a single displacement reaction? I have a compound, all right, then I've got another element. What's going to happen?
So then the sodium will get switched out so that it's on its own line.
Good, very good. So this lithium is literally going to displace or move away the sodium. And we would get, instead, lithium chloride. And lithium chloride has what formula? What charge does lithium take? And chlorine takes what charge? -1, so we would get LiCl. Good. And what else will I have? Very good. Does that make sense? Okay. So on your note, then, we're looking for the general form. The general form, this is that first space you have. And the general form looks like this. If we have some compound AB and some other thing C, what's it going to look like? Very good. Very good. Some variation thereof. When you're looking at a reaction, what will be the giveaway that you're looking at a single displacement reaction? I'm going to try this one more time. What will be the giveaway that you're looking at a single displacement reaction when you look at a reaction like this? I mean, before the reactions happened, in terms of like if somebody's telling you to do a lab and they say they're doing this reaction, type it is, how will you know it's a single displacement reaction? Very good. If you have a compound and an element, then likely you're going to get a displacement reaction. Does that make sense? That's not a guarantee. You could get a synthesis reaction where they just all come together and you only get one product. But it's a good hint that you at least need to think about the possibility of a single displacement reaction. Okay, so there's an example there for you to do. Hey, we're back together now. Look at that. I never doubted me. So I want you to do solid magnesium reacting with copper 2 sulfate. Give that a try. Solid magnesium with copper 2 sulfate. You need to, but you don't have to. Not sulfate, not sulfate. Excellent. Good. You got magnesium. Copper 2 sulfate. Oh. See, that's. All right. So copper. Let's just do what I will with this. Copper takes what charge? Right? And which one is it? Yeah, unsulfate. And the sulfide. And always 2 and 2. Where are they going to be? So how many of these do we need? Yeah. So that whole thing in there. Let's see. Yeah. And now you can draw your arrow, and now you have to use this to make it connect. Okay, so let's stay on. What do I do? The first thing I'm going to do is formal for magnesium. Yeah, that's just solid. What are them? Because you need to the last day. And then react to it. And now we need so let's hold it on the side. Let's just do some rocket.
What charge? And we know because it's the two that it's going to take. Okay. Now we need to unsolve it. Complete tells me it's going to be 1 hydrox. So see if we can unsolve it. Hydrogen sulfate, but we want this sulfate. So this is a copper hydrogen sulfate. Sulfate. There you go. So what is it? And it's charged with. It just goes below. And SO. Cool. Okay. Now, the charge of this is. The charge of this is. Get the cancel stuff. Okay, so the formula for this thing will just be. Plus. And then C. And these are going to react. And just like that, what's going to happen? This thing in front is going to be one. Yeah, but specifically, it takes place. Like, if you look, he gets kicked out, and then it's A's. And then now we have to check what's the charge on one of these. If it's 2 plus, you don't have to worry about it.
I can solve it for 6 years. I can.
And then what's left?
Every year I have it's only 1 month.
Very good. It's no longer just, now it's on tablet. Okay. How are we doing? So we're starting with magnesium. Can I borrow? You have 2 copies left. Can I borrow one? Thank you so much. So magnesium oxide. Right, good. All right, and then copper sulfate. So I don't know how you had Vargas. I don't know how Vargas. You got crisscross rule. Whatever you believe. We're figuring out like what formula something is. Something like copper.
I would make.
Okay, so let's just go over here using methods. So copper 2 is going to be copper with what charge? Yeah, so just split it up here. C2+. Right? And then sulfate is one of our radicals, right? It's one of these guys. So see if you can find sulfate in here in alphabetical order. You told me sulfate. This one right here. SO4, and its charge is. Yeah, so you can select next to it.
I didn't realize we're charging.
That's right. And then the formula for this thing would be.
No.
But if you're not sure, I can tell you how I do.
Yeah, I don't
No problem. So this is so copper 2 sulfate is like copper with a 2 plus charge. This comes together with sulfate. And the thing when we put a compound together is the charges always have to cancel. So if you're lucky, they're the same but opposite.
Yeah,
And I think you're
so tired.
the copper has a charge of, and sulfate has a charge
I
of.
had to make them.
Yep. So do those cancel? Yeah, so we don't need to put any numbers in it, it's just be sch3u SO4. 1 copper, 1 sulfate, it leaves. So the formula for this would just be sch3u SO4. Yep, so sch3u, and then SO4. There's no trust or anything, right? This is all, and this one is that flows down below, right? Right? Great, and now I'll do the rest together, just because that's the active part for today. All right, so let's take a look here. This reaction is solid magnesium and copper 2 sulfate. What's the formula for solid magnesium? Yeah, Alondra.
MG
Mg. Great. And how would I indicate that solid?
with an S.
Like that?
No.
With a little bracket?
No.
I'm just being difficult. I'm sorry. Like this?
There you
Okay.
go.
Thank you. That's funny though, right? I'm funny? Okay. Now we're going to react this with copper sulfate. You're all good. Thank you. Okay. Now here's something you need to know. Every time we go to make an ionic compound, we have to figure out its formula, right? So you're going to get really in the habit of going to your margins and doing some rough work to figure formulae out. Does that make sense? You just have to do it.
So copper 2 sulfate, what's the cation here? Copper, and what charge does it have? 2. How'd you know that? Because copper can be 1 or 2. Yeah, it's right in the name, right? Okay, and then what's the anion here? SO4. And what charge does that take? -2. Okay, now to put these together, the charges have to cancel. Does this one work nicely?
Yes.
Great, so what's the formula for this? Oh, I'm sorry. There you go, sir. CuSO4. Okay, and I'm going to introduce here, reactions like this usually happen dissolved in water. So I'm going to put AQ. Does everyone remember what AQ stands for?
Aquarius.
Not Aquarius. Aquarius is a sign of the zodiac, which is good, but aqueous. Aqueous, if you think, yeah, aqua, the Latin word for water, literally means happening in water. All right? So dissolved in water. You didn't need to know that. You'll know that plenty once we get going, but I'm just going to put there because we know. Now, what kind of reaction do we get here? We're going to get a displacement reaction, which means what?
Magnesium and copper.
Good. Magnesium and copper. Magnesium will displace copper. It'll switch places with copper. The scientist in me wants to say displace, but I'm going to say switch places for simplicity's sake. Bless you. To me, a single displacement reaction is just like a date gone really badly. Not that I, of course, have any experience with that, you know, being charming and irresistible and all, but just imagine hypothetically, you know, it's like, you know, B and C are going out on a date and they go somewhere and by the end of the night, A and C are together and poor B. B's just all alone. Does that make sense? It's just a really unsuccessful date. But, you know, B was always too good for C anyway, and I think he's going to be happier, really, in the long run. You know, one day C will know what he's missing. Anyway, so in this case, copper and sulfate are on a date, and what's going to happen at the end?
Sulfate moves on.
Yeah, sulfate moves on. Sulfate sees that the grass is always greener on the other side. So on the right side of this reaction, what's going to be all by itself?
Copper.
Copper.
Because copper feels better about itself being alone there.
Yeah, copper's happy. Copper trusts itself. And what's the compound going to be? It's going to be magnesium sulfate. And then I have to figure out what? I have to figure out the formula for that, right? I can't just assume this happens to be one that works nicely, where it works 1-to-1, but you can't assume that. Knowing that the product is going to be magnesium sulfate, now I have to go to the margins and do the work and figure out what the formula for magnesium sulfate is going to be. Does that make sense? Every time you make a new compound in chemistry, you got to go to the margins and figure out what the formula for that's going to be. So how would I do that? How do I figure out the formula for magnesium sulfate? Yeah. Great. So what's magnesium's charge? Great. And what's the anion again? All right. So this case, what's the formula? MgSO4, because a 2+ charge and a 2- charge cancel one another. That's balanced. Be quiet. Not you. It. Yes.
Yeah, I agree with you.
Yeah, of course. All right. So there we have it. That's the first one done. In grade 10, did you have to do them just from names like that? Did they give you 2 names and you had to work out the products? Yeah? Good. Yeah, absolutely. Good. Okay. Now, one thing to keep in mind is that like displaces like. What do I mean by that? Like displaces like. Well, what did magnesium displace here? Yeah, it displaced the cation. Could magnesium have displaced the sulfate, giving us SO4, sulfur tetraoxide, and magnesium copperide? Could that have happened? Yeah, absolutely. No, of course not, right? So as a rule of thumb, Metals replace metals. And you're right, it would be more accurate to say cations replace cations, but I'm going to write it this way because it's easier to remember. Metals replace metals, and nonmetals replace nonmetals. Good. What indeed. Now again, this is a bit of a hypersimplification. The more accurate thing to say is cations will replace cations, anions will replace anions. But I like to say it this way because it's just easier looking at the table to tell quickly. Does that make sense? The flip side is this doesn't work 100% of the time as a rule, but it's a good rule of thumb. Does that make sense? Cations replace cations, anions replace anions. If copper can only form positively charged ions, the only thing it can kick out is the positively charged ion. Does that make sense? Okay, I want you to try the two questions below. A balanced chemical equation for a reaction between iron and silver nitrate, and a balanced equation between chlorine gas and sodium bromide. All right, practice those two. Oh, and I don't tell you which one to use, so let's use the 2+ for ions. Let's all do the same one. Let's all use the 2+ ion in our answer. And I'll put a little note up here. Yeah, just so we all do the same thing. Let's all use the iron 2 ion. By the way, does that, whether it's iron 2 or 3, does that affect it when it's on the left side by itself? No, it only affects it when you actually make the compound. That's right. That's right. As this lists all the possible charges, you really will find your life is a lot happier if you use. I know, but I'm just saying in general as we get going. Just give me advice. You do what you like. Who am I, right? Exactly. Just. Yes, ma'am. Yeah, in fact, it has to. You can have to.
Does that mean you have to
Yeah.
and then
Yes. Yes, very well done. Exactly right.
wait.
Excellent. Good job. Very well done.
Sticky in my teeth.
Oh. Stop freaking gas.
I thought I didn't.
So when iron's on its own, it doesn't have a test.
Oh, and you stole it.
I didn't pay attention.
I wasn't here. Oh, we have a meeting.
Yes. Yeah, every Friday, unless it says not, but.
Sucks that I can only be that for now, but I haven't.
Co-op, yeah.
AG is +1, and 3 is -1. So they're able
We actually literally just started to talk about like donations and everything and like fundraising right after you left. I was like, oh no, where's the launch run?
You talk about all the stuff that I need to do.
Yeah, I know. I was like,
with the stuff that I don't need to do.
yeah.
So why don't we talk about
I think
fundraising?
that's what I wanted to talk about today. Anyways, we have to get that sorted out. We have to start that soon, and then we have to get the letters and everything. And I wanted to start talking about like because we already have like the songs. We have to get the order of the songs. And then after that, we're gonna do decorations.
Well, once we have like the letters, I already got a bunch of places that I have permission to go bug.
Yeah, good to go bug.
There's my old workplace at the pet food outlets.
Mhm.
He said that he'll
Oh, you used to work there?
Yeah.
What?
He says that he will help with anything at all.
Aw.
So
Okay, yeah.
even for the musical and planning, 3 things he's wanting to read.
Oh my gosh, that's so sweet.
Yeah, because he liked you. You actually just put the you're supposed to do.
Yeah, I was gonna say, doesn't like Tyler work there, and he doesn't really do much. Sits it on his phone.
He gave me 50 bucks at the end out of his pocket.
Really? Oh, that's so sweet. Yeah, it's like a family-run company, right? Yeah. Besides
Which
you.
did like a paid club. And so
Oh, and that was your summer thing?
I was supposed to be working there for free, but he gave me 50 bucks out of his pocket.
Really?
Good job.
Wait, you got the co-op credits in summer? That's cool.
And he also gave me vacation.
Oh my gosh.
I was happy. I got the pay price, so I was at first sale.
Wait, was that like the summer that just passed?
Yeah.
Was that like that program that we did upstairs that I left? Yeah, okay.
Yeah, he's really nice. He even, for my co-op, I needed one extra person, and he was the very first person to write back to my co-op. He never told me his last name.
Really? I actually heard it before because Tyler told me before.
I had to call him, because the entire time I said, he's just like, oh no, just call him.
Call you Tim?
Yep.
That's funny.
Not his full name, Timothy, just Tim, just Tim.
I had telling me this real name too.
Now you're gonna put number one on the now you have two nitrates, which is good.
It's a hot drink.
But you also
So it's
have.
chlorine.
It's still good. I know three, I have three, two of them, two of them. But how many solars do we have over here? Two. And how many over here? That's a big two. The numbers in front are always my favorite ones. Good. No problem. No problem. Okay. How are you?
You're not sure.
Oh, listen, so is chlorine is a what? Okay, tell me that. But you remember that's. Well, that's a nonsense. But what is it? It is a. It's a diatomic. It reacts with sodium bromide. Let's assume this happens.
Okay, I'm done. Bromide to hot sprinkle. I forgot that. I forgot about that hot sprinkle.
Bromine, at least now bromine will form what?
Thank you.
Will it? I'm not so sure.
You don't have to.
Yeah, it's diatomic.
It has to be.
Periodic table, and I think it's nothing but gas.
There's in there. Oh, that was much for me.
Well, bromine is.
Pure and feel are both non-metal.
Diatomic gases. Well, diatomic compounds. So it should be in our. Yeah.
Yes.
What does she do? She sends me to the door.
Some water, and you know,
Yeah, not when you put me the compound. On compound, it's required to use.
hold on. You're right, it does. So, NO3, this is a whole thing.
Wow. In the compound, it only requires one compound to make the compound. Ta-da! There you
And fix that.
All four of my mom cats.
And you're done. You did great. Yeah, that's fantastic.
Dinah.
Well done.
And then.
The secretaries are so nice.
Good, but bromine as well is
Two.
atomic, so you gotta balance.
I came back to my car and getting home, and they gave me a bus pass. Every single one until the secretary.
Arrows, natural science. We're doing chemistry, not math. No. If I always put poison in my macaroni and cheese, it doesn't make it right.
I made an error.
No. No. Chemistry's a lot of things that isn't cute. I don't know. We'll take it up. We'll take it up.
There, I made arrows for her.
I don't know. Take it up.
No, yeah, I can't. I don't know if,
Hopefully on the right track. A couple little details. But you're real close. That's good. That's a very good start. Okay. A couple things you got fixed. Let's take a look. Okay. Let's try this. Let's try this. Okay. This is seriously how the cavemen taught using tablets and projectors. Well-known fact that the cavemen had cables connecting their tablets to their projectors. So let's talk about when cavemen were like mice. They just ate everything they came into contact with. You know, one day when I teach a history class, which I never will, but I wish I could, we can talk about the fallacy of assuming everyone in the past was an idiot, which, by the way, not true.
Well,
When you think how much smarter a caveman had to be to survive than we are, like, just stop and think about that. We like to think we're smart because we're like, well, we have computers, but like, you couldn't make a computer. Like, but again, like you know, like, if you're hungry, you just like go to the grocery store and give them a piece of paper and they give you food. They had to like capture their food in the wild. Just think about that. I mean, they were undoubtedly much more clever than we are.
yeah, but they didn't live long.
It had to be. So
They had
yeah, you wouldn't live long either. So anyway, let's take a look. So we're reacting iron and silver nitrates. Let's start with chemical formulae. What's the formula for iron when it's all by itself?
Fe plus.
Now, when it's by itself, does it have a charge? If you touch a piece of metal, do you get immediately electrically shocked because it's really charged? No. So when metal's by itself, no charge. It's gonna have a charge when we.
I meant like just like I thought you like wanted to name like them everything.
Oh no, we'll get there. Yeah. So over here it's just Fe, right?
Yeah.
Now for silver nitrate, I'm gonna have to do a little rough work in the margins, right? What's silver? AG, what charge does it take? Nice. What's nitrate? Great. Do I have to mess around with this, or is it nice?
It's nice.
Great. So what's the formula?
AgNO3.
Very good. Okay, now, this single displacement reaction. Right now, silver and nitrate are on a date. What's going on?
Nitrate.
Kind of boring. Nitrate won't stop, silver won't stop talking about its like hockey card collection, and nitrate's thinking, God, I just don't care. I can't believe I let sulfate set me up on this date. This is terrible. And then in walks iron, wearing like cowboy boots and a Stetson. And nitrate's like, whoa. All right, so what happens?
They did them.
Yeah. All right, so who's by himself now?
AG.
AG.
To talk about the Pokemon.
And what state of matter is silver here? Solid. And then I have to put +1 here, right? Because silver takes +1 charge? No? Why not? Oh, right. Yeah, because it's just solid silver. It's all on its own. Okay, and then what's the compound going to be?
Fe bracket NO3 bracket 2.
Okay, good. What's it called? What is that? You're right.
What's called?
What is that compound? You're right. Like, what would the name of that be?
Iron nitrate
Good. And iron
2.
2. Good. Okay, so I want to know how you figured that out. So what's the charge on iron? 2+. And nitrate? Okay. Is this charge balanced? No. To make it balanced, what do I need? Yeah, I need to double this. Does that make sense? I need 2 nitrates to cancel. That's the only thing you're missing on there. So how do I write that now? So I need my iron like that. Then how do I say here that I need 2 nitrates? Do I go NO3 2 like that? Why not? What does that look like? Yeah, it looks like there's 32 oxygens. That doesn't work. So how do I do it? Yep. Exactly. Just like that. Good. And I'm done. I'm done. It works. It's perfect. No? Why not? I think I'm done. I like being done. I'm going to put a therefore statement. Is that what I'm missing, my therefore statement?
No,
Therefore, I'm done.
it's not equal. It's not equal.
What's not equal?
On each side, there's 2 NO3s on one side and 1 on the other.
Oh, okay. How many nitrates do I have over here? 2 of them. How many nitrates do I have over here?
No,
Okay, no problem. I'm just going to do this.
no. Now you're just changing the formula.
Oh, I'm changing the formula. I can't do that. So where do I have to put my 2? Oh, uh-oh.
Oh, now you really.
Oh, I flew too close to the sun. Okay, there we go. So where's the only place I can put the 2? In front. Good. But now I'm done.
No.
I think I am.
No.
I put the 2 there.
We-
I'm going to put the first statement.
Now there's 2 AG on the one side and 1 on the other.
I'm moving on.
No. You can't move on with your life. It's too big of an.
Okay, so what's the problem? What am I missing? Yeah, because to balance this, I needed 2 of these, so now I have 2 nitrates, but that means this now requires me to use 2 silvers as well. So I'm going to end up with 2 silvers. Because charge has to always balance, but mass also has to balance, right? I can't create atoms, I can't lose atoms. Now I'm done.
Yep, now you can move on with your life.
Fantastic.
No, not quite.
Yeah, now I should probably put states of matter here, but we haven't talked about this. And this reaction could potentially happen by sprinkling solid iron over solid this, but it's more likely that this happened in a test tube dissolved in water. So I'm going to say it was probably aqueous. But it could potentially happen either way. All right. So again, you guys looked like you're doing great. Like we had a real simple miss there, but by and large, really well done. Good. Now let's talk about this next one. Chlorine gas and sodium bromide. Okay, so chlorine is a gas, and then over here,
It's chlorine 2.
oh, it's chlorine 2. Why is it chlorine 2?
It's diatomic.
Why do we need 2 there? It is? Yeah, we remember it with that word Hofbrinkel. But these are the diatomic gases. Well, the diatomic elements. They're not always gases. So when we find the diatomics, they're always found in pairs. Yeah? Okay, now this is reacting with what? Sodium bromide. So again, every time you come across a new compound, got to go to the margins. Yes, eventually you'll skip this step because you'll just know them. But for now, I've got to go to the margins. So how am I going to figure out the formula for sodium bromide? Okay, so what's sodium's charge? +1. What's bromine's charge? -1. Okay, so what's the formula going to be? An ABR. Fantastic. Because the charge is balanced, I don't have to put numbers with it. I don't need 2 sodiums. I don't need 2 bromines. It's just sodium bromide. And you could do this in water. You could do this with the solid. Doesn't actually matter. I'm going to pretend that we put this solid in a gas chamber, but you could just as easily have done it dissolved in water. That's fine. I didn't tell you in the question, did I? Nope. Okay, now again, sodium and bromine are on a date. Bromine is discussing Indo-Eurasian politics. Sodium is thinking, I could be at home reading a book right now. And then what happens?
Chlorine comes in and sees bromine.
Great, so chlorine's going to show up, and chlorine is going to kick sodium out. We will have sodium all by itself and get ClBr, right? What do you mean no? I just wrote it down. I'm the teacher. Oh, I forgot the plus sign between. Great, I'm the teacher, so I'm right, right? But I'm the teacher. I'm getting paid right now.
Oh, yeah.
It's not balanced. Okay, well, I'll balance it. There we go, it's balanced. Is this right? What did I forget? Oh, I switched unlike terms. We can't forget that like displaces like, right? And listen, that is a very common error to make. Very, very common error to make. But we have to remember that like is going to displace like. Chlorine, is it a metal or a non-metal? It's a non-metal, which means it's going to make a cation or an anion. It's going to make an anion. So what's it going to kick out? Yeah, it's going to take the place of bromine, not the place of chlorine, not the place of sodium, rather. Now, if you made that mistake, good. I was trying to get you to make that mistake. That's what I was trying to do. I'm leading you down the garden path. But yeah, remember, like displaces like. We learn more from our mistakes. That's important. things stick in your memory when you screw them up. You go like, oh, I remember screwing that up. And hopefully that helps us. So rather than me just putting up here a note where I say, don't forget, this is if I can make you screw up, then I've won. If you outsmarted me, even better. So now, if chlorine kicks out bromine, what's going to be by itself on the right side? Bromine, which looks like this. And
Oh, no.
what do you mean no?
It's a hot
Do I have to remind you that I'm the teacher?
It's a hot one.
All right, fine. It looks like that.
We might have to make you stand up and sing the song.
Why? Why not? Oh, it's not gas. What is it? It's a liquid. How'd you know that, you clever kid, you? Yeah, if we look up there, the bromine and mercury. What's true about them on that periodic table? The blue, what's that mean? The liquids at room temperature. Liquids at room temperature. Okay, so we got bromine gas. And what is the name of the compound we get going to be? What is it? We're going to get sodium chloride. What charge does sodium take? And what charge does chlorine take? Okay, so what's the formula for this going to be? NaCl. Good. I think it is that.
No. You gotta put a 2 in front of it.
Well, we're not there yet. We're not there yet.
That's not a solid.
So salt isn't a solid?
Oh.
I think it is, with all due respect.
I thought it was like
I appreciate, I like that you're just like racing to find things I'm doing wrong. No, listen, this is good. Is this what happens when I make mistakes constantly? You don't trust me anymore? You just assume I'm wrong? Okay, so now, but you are completely correct. This is not balanced because I've got 2 chlorine here and I've got only 1 here. So what do I need to do? Put 2 there. Great. So am I balanced now? Okay, and here?
No.
No, not there.
Oh.
There we go. Okay. Good. And now are we done? Great. Good job, guys. Does that make sense? All right. So now that's what we did in grade 10. And hopefully you did a lot of that in grade 10. But don't worry, if you didn't, you're going to do lots this year. Oh, golly, are you going to do lots this year? So don't worry. You're going to win so much, you're going to be tired of winning. But we have to add one more element to it. And here's what I want to say. Let's take a look at this. Let's take a look at this, and I'm going to use my cheat sheet so I don't screw it up. Let's say that Okay. I'm sitting on the cheat sheet. Okay, let's say I have magnesium oxide. Hey, can anyone really quickly tell me what the formula for magnesium oxide would be?
MG2O.
Which is it? I'm hearing Mg2O, I'm hearing MgO.
Oh, no,
Which is it?
MgO.
What is it? Okay, let's take a look over here. What charge does magnesium take? Does it? What charge does magnesium? 2. Okay, and what charge does oxygen take? -2. So what's the formula going to be? MgO. Cool. Okay. And we're going to dissolve this in water. And then I'm going to drop some potassium in there. All right, I'm going to add potassium.
No, not potassium.
Okay. What's going to happen? What's going to happen? Yep.
K is going to kick MG out and seal it down.
Okay, so K is going to kick Mg out. And what's that? So what's going to be on its own on the right then? All right, I like it. So we're going to get magnesium forming. And what will the compound be? What is it? Yeah, and let's just double check that. Potassium takes what charge? Yeah, and oxygen takes what charge? Great, so for those charges to cancel, what do I need? 2 of these guys, right? Does that make sense? right? They're going to meet at 2. And so it takes 2 potassium to do that, and it takes just 1 oxygen to do that. So I'm going to have K2O. Okay. And is this balanced? What do I need? Okay, now are we balanced? I think we are, aren't we?
Yeah.
Okay, good, we are. Great, perfect. Okay, so this reaction happens, and this reaction does happen. I could go right now to the back, I could get magnesium oxide, I could get potassium metal, we could go on the bench and we could do this reaction. And it happens, and I will end up with solid magnesium, and I'll end up with potassium oxide. So if I do the math on this right, I could make it happen exactly. I could take all of that magnesium oxide and turn it all into magnesium and potassium oxide. Now here's the problem. What do I then have sitting in my test tube? I now have magnesium and potassium oxide, right? Let me ask you this. Could these react? Yeah, so here's my question. And like, without even thinking, what would it have to do? Magnesium would have to kick out. Okay, so what's going to be by itself over here? Okay, and what's the new compound going to be? MgO. And how many of these do I need? Okay, there we go. So here's my problem. In theory, if I put magnesium oxide and potassium in my test tube, they should react, and then they should go back. And then, oh, I've got the first thing again. They should go back. And then I've got the second thing again, so they should go back. But that doesn't happen. You tell me? Why not? You are so snarky. You with your blanket. Yeah, why not? Why does the first one happen? And it does. It does. On the bench, we can make that happen. But it doesn't just happen. It happens, and then it stays like that. And you know this, because in grade 10, I guarantee that at some point you did a lab where you did single displacement reactions. And they happened, and you saw them, right? With the stupid little dropper plate, and you drop a drop in, and it turns white and cloudy. Really? Oh, okay. Well, don't worry, because you can do one on Wednesday next week. But I promise, you can make that reaction happen, and it doesn't just happen. It doesn't immediately undo itself either. It happens, and it stays. Well, but I didn't in the first case. Why would I have to in the second case?
The second formula is another reaction.
Ah, yeah. Remember how I said it's like a date? My wife and I go on a date. And he's somebody very attractive other than me. I mean, I know me, but I mean someone else. Like Channing Tatum shows up. After I'm done beating him up, because I'm very tough. That's one of the first things people notice about me. So, you know, just like the single displacement reaction, Joe's going home alone, and now Brittany Orlando is Brittany Tatum. I don't know. So there we go. The date's gone bad. I lose my partner. Is it immediately true that if Channing Tatum and now his wife show up, I can be like, sorry, sir, I think I'll slide in here. Is that going to be just as effective? No. Yeah, probably not, right? Like realistically speaking, if first date went bad, it went bad for a reason. And the reason it went bad is because potassium is more interesting to oxygen than magnesium was. Magnesium is talking about stock portfolio, and potassium's got that Stetson hat and the snakeskin boots. And it's just like there's no comparison, right? Does that make sense?
And there's 2 of them.
So every possible reaction doesn't happen. They have to have a reason to react. Nobody's going to dump their girlfriend for like somebody who has like less money and is more boring, right? That doesn't happen, does it? I don't think so. So just like that, the actual actors involved here, the chemical species involved, matter. And you know this because remember we talked about like electronegativity and stuff? Everything doesn't share equally. Now this isn't just a matter of electronegativity. There's lots of factors involved. Because this isn't all about pull-on electrons, right? Because, for example, lithium, sodium, potassium, all those, they're not trying to get electrons. They're trying to get rid of electrons. Does that make sense? But in general, we can say this. Some things are more reactive than other things. Some things are more reactive than other things. So this is a chart called the activity series. And this is a chart that tells you how reactive different metals are. And I want you to look these two reactions up on the chart. Now, what we're talking about when we talk about activity is the thing that's going to do the kicking out and the thing that's going to get kicked out. So in this case, it's all about magnesium and potassium. The oxygen isn't important. The question is, who's the better dancer? Who's the better dancer? Magnesium or potassium? So if you look here, now this doesn't have every metal on the periodic table, but it's got some of the most common elements that we use. And if we take a look here, where does potassium fall on this list? It's one of the most reactive. In fact, what are the only things more reactive than potassium? Rubidium and lithium. Good. So everything else, including magnesium, is less reactive. The further down we go, the less reactive. Does that make sense? So here's the rule of thumb. The more reactive you are, the better the dancer you are, you can kick out everything below you. Does that make sense? That makes sense. You can always displace something less reactive than you. So potassium walks into the bar and sees magnesium with oxygen, potassium, and be like, it's my dance, buddy. Does that make sense? You can kick it out. That top reaction happens because potassium is more reactive than magnesium. Happens. Potassium is more reactive than magnesium. Potassium is Channing Tatum to magnesium's, let's say, I'm trying to think of
Jonah Hill.
Jonah Hill. There we go. Which one's he?
Have you seen 21 Jump Street?
No.
Oh, he's the less attractive partner.
Oh, okay. Well, there you go. Then that works. All right. So now this bottom reaction, on the other hand, can't happen. And it can't happen because Mg is not more reactive than potassium. Does that make sense? So in grade 11, it's not enough to be able to come up with the name for every formula, the formula for every name. It's not enough to be able to come up with the reaction and balance it. You also have to ask yourself, can this reaction actually happen in real life? Does that make sense? We want to know about that. And for a single displacement reaction, and by the way, this activity series is specific to single displacement reactions. Does that make sense? That's what the activity series measures. It measures the ability of a metal to displace another metal in single displacement reactions. I want to stress that. When we do double displacement reactions, this will tell you nothing. Okay? So this is useful for single displacement reactions and for single displacement reactions only. Is this useful to me if I'm doing synthesis reactions? No, because nothing's displacing anything. So the relative reactivities don't matter. Is this relevant if I'm doing decomposition reactions? No, because again, nothing's replacing anything. It's just splitting apart. This only applies to single displacement reactions. Yep. Well, the thing with a double displacement reaction is it's a metal replacing another metal, but then on the other side, it's also a metal replacing another metal, right? So in a double displacement reaction, no matter what, a metal is displacing the other metal in both directions. So 50% of the time, by definition, it has to be breaking this rule. So double displacement reactions happen for a whole different set of reasons, and we'll talk about them when we do that lesson. Did that answer make any sense? Yeah, a little bit? Okay.
It's very confusing.
Then ignore it, because we'll get to it when we get. Long story short, when you see a single displacement reaction, this is what you need to look at to ask, will this happen or will it not? Did I forget to hole punch this for you? That's frustrating. The hole punch is up here. We can use it at the end. Okay. So at the activity series, here's the rule. A single displacement reaction. Is everyone comfortable if I just shorten that like that? A single displacement reaction will happen if the displacing metal is higher on the activity series. By the way, if you look, I didn't just give you the activity series of metals. I also gave you the activity series of the non-metals that could displace them. So it's not always the metal you're looking at, but the thing that's doing the kicking out, the thing that starts by itself needs to be higher on the chart. Maybe you even want to put it in that language. The thing that starts out by itself needs to be higher on the table for it to work. I mean, I use the language, the displacing element, but when I say the displacing element, I mean the thing that starts out on its own. All right? That's your Channing Tatum. Or potentially your Jonah Hill, but if it's Jonah Hill, I'm being told that that doesn't happen. I'm being told that if Ruby and Channing Tatum were on a date and Jonah Hill walked in, she would not undergo a single displacement reaction.
I don't know.
Well, you told me that,
Yeah,
Ruby. Come on now. So this is the thing that starts out by itself.
Can't do C.
Good, good. Please announce to everyone. Or let them do their work. Okay.
I know, like, it's impossible. We don't know what compound it is.
Well, it doesn't mean you can't do it. It means how many answers will there be? Far from meaning that you can't do it, it means you have to do it twice. Once for copper, 1, and once for copper, 2. So there's 2 possible reactions. Unless it's one of the impossible ones. Yeah, so that's something I want to tell you. We didn't do it in class because I didn't want to take all day. But when you get to one where there's 2 possible reactions, because it can make 2 possible ions, I want you to do both. I want you to tell me what the reaction looks like if we use the 2+ ion. I want you to tell me what the reaction looks like if we use the 3+ ion. So you'll have 2 equations to answer those. Of course, yeah, sorry. All right, so I left you with a bit of homework on there. Yeah. I mean, you got 11 minutes. You might be able to finish it in class. Yeah. And let me tell you this. In this unit, the best advice I can give you is this. And listen, I know teachers harp on about crap like this constantly. You can choose to believe me, you can choose to ignore me. But take it from somebody who has got 90s in university chemistry classes and who has also had the humiliating indignity of writing a final exam in a university chemistry class and getting 17%. Yeah, that happened to me. 17% on an organic chemistry final. It was not fun. I almost cried. I did. I was this friggin' close. An hour and a half into a 3-hour exam, I had actually not written a single thing other than my name. I had gone through this. It was a 12-page exam. Every page was one question. I went to page 1 and went, okay. I'm going to come back. I went to page 2 and went, okay, yeah, I'll come back to this one. And so by the time I got page 12, I was like, okay. I don't know any of these. Now I'm going to pick a random page and try that for a while. It was bad. So listen. So take it from somebody who has experience being well prepared and experience being ill prepared. Is anyone an athlete like me? I'm an athlete, obviously. Is anyone else an athlete in here? Okay. If you want to learn basketball, or if you want to learn volleyball, listen. I want you to imagine you go to basketball practice. Coach says we're doing layup drills. You do one layup, and then you go, got layups down.
Yeah, no.
And then it's like free throws, and you go, hey, I sunk one. You know, the first 2 I missed, but I sunk one. Got free throws down, and then you go like hit showers, and then like eat pork rinds. You gonna make the team?
No.
No chance. And here's the thing, we have moved into this idea in teaching of like, you know, it should be discovery-based, which I think is true, and it should be inquiry-based, which I think is true. But then sometimes we act like it's a bad thing to ask people to just do repetitive practice. Well, guess what? That's how we get good at things. And if you tried to go to like a basketball coach in the NBA and say, don't make them do repetitive practice, they laugh you out of the room, right? The fact of the matter is this: how do we learn to get really good at something? Repetition. Okay? There's no substitute for it in anything in life. Okay? I get here quite early in the morning, and do you know what I'm often greeted with from the right side of my ear as I make that left turn to this down by the office to the hallway? I'm greeted to the sounds of a piano being played in the building. Thank you, by the way. It's often lovely. How do you get excellent at an instrument? The first time you play something from sheet music and get it right, you stop and you never play it again? It doesn't work that way. It just can't work that way. You have to develop facility, all right? You have to get to the point. Do you know what the word facility means? In French, facile. Easy. We are good at something, we have something as an ability, our facility with something is there if when you do it, it is simple. When have you practiced this enough? When you look at every question and you don't have to think about it, you go, yeah, that's simple, got it, write it down. And that's when you've done enough practice. Does that make sense? So this is like day one of practice, but then I'm just gonna feed you huge worksheets. Do I have time to take up 100 questions in class? Yes. Of course I don't. Of course I don't. But you need to do as many as you have to do until it's easy, and it's different for different people. All right. If I and decided we were going to commit our lives to marathon running tomorrow, I suspect that some of you would get to the point of being able to do that a little bit quicker than I would. All right. That's reality. Despite all the feel-goodisms we like to throw around, the fact of the matter is people do indeed have natural abilities. Someone may be able to do 5 of these questions, and they have got it. Good for them. That's great. I wasn't that kind of student, but if you are, awesome. You may have to do 50 of these things. There may not be enough practice on this page for you. To some extent, you're in grade 11 or grade 12, college or university level, you have to take ownership of that. Does that make sense? If you get through 8 questions, and the 8th one was hard for you, it means you need more practice. There's no shame in that. There's nothing wrong with that. You've got to seek it out. Just ask me, hey, can we go over a couple of questions together? Can you give me 5 more questions? Can I show you what I'm doing and see if you can tell me what maybe I'm struggling with? Does that make sense? But you've got to figure out what amount of practice works for you. And that's very individual. Very individual. I'm talking. I'm being very rude. You understand that? I'm talking is talking right over top. Don't do that. It's impolite. One day when you're teaching and I'm taking your class because they've sent me back to high school and I realize that I never actually graduated, I won't talk during your class. Right now it's my turn. So again, when it comes to practice, it's very individual. You have to figure out how much you need and then do that much. Okay? Because if I give everyone 200 questions, I'm overloading some people. But if I give everyone 10 like this, some people are going to need more. Again, nothing wrong with that. No shame in that. And the truth is, the person who has to work harder to get it gets it more deeply and more fully when they finally do get it. That is what I found in my life. The things I'm best at are the things I struggle to learn. Yeah, push through. Okay, end of spiel. Yes, ma'am.
What does it mean by metal or what?
Sorry?
What do you mean by metal?
That's actually quite interesting. Red phosphorus. I don't know. Sorry?
You didn't tell us.
You're right. I want you to do it twice.
Yeah, it wasn't fun doing it twice.
So I want you to do it. I want you to answer the question once, assuming we use the copper one ion. I want you to answer the question a second time. And see, oh, did you just roll your eyes at me? No, I'll knock you out. I'll knock you straight out. Roll your eyes at me. Anyway. Are you? Oh, I'm sorry. Well, now I feel guilty for threatening myself. Yeah, I want you to answer twice.
I don't know how to roll my eyes.
My favorite is like my kids have heard of rolling their eyes, so they now understand that they're supposed to if they find something irritating. So my son does these big, like exaggerated, like. It's like, yeah, that's really not how it works. It's got to be a bit more subtle than that. But he's working on the subtlety. Oh, really? Did I? It's one of these things that are like, I don't know. It's like social, right? You just don't know until someone teaches you. I remember the first time I was just using stuff, right? Finally, one of the kids was like, "What are you doing? Like, what's wrong with you?" I don't know. As I'm like, it's like, that stuff's expensive. Like, you need like this much of it. But like, you don't know.
Oh, right.
But you know,
Does it not react?
yeah, you gotta check.
It does not react.
By the way, guys, a piece of advice, and this piece of advice is going to apply for the whole course. When you get a list of things like this, get a piece of line paper out and give yourself some space. Don't try to cram your answers into like little tiny spaces.
Too late.
We think better when we have room to breathe, all right?
I have tiny writing.
Well, but also, like, that is hard to follow. You acknowledge that, right? Like,
But it's right.
okay, but like, you know, if
I figured out what red phosphorus is. Phosphorus can come in 3 different colors naturally, and it's saying that the red phosphorus is the least rare.
I don't like being on that, so I'm just like,
It comes in white, black, and red.
that's really interesting. I did not know that.
I taught a teacher.
Oh, I learn every day I learn. That's really cool. And that has to do with like how it's extracted from words.
why are you getting excited?
What were they, red, white, and black?
Yeah, I think it's I've got to teach before this.
Spelling at the board is the worst thing. You psych yourself out. You put a word up on the board, and then you're like, is it right? It looks wrong. I think it's wrong. And then
He just looked at the class and he was like, I'm just letting you, if I spell something wrong, you're yelling.
fair enough.
So it worked.
Yeah, it doesn't make any sense.
My thing is, I need to. Oh, we
I got on the bus.
Oh, they should think that about it.
Who is this test?
No. Okay. She's speaking the entire day. And got Chelsea. Oh, Chelsea said, I'll take care of you, but I'm not up with you. Then Chelsea better speak off. I know.
Oh, I've got to say it.
Yeah, I'm gonna fail.
I failed math. If I fail math, it's all your fault.
And she was just trying to do nice things. Well, when you were doing the wrong thing.
Exactly.
Then they're going to figure out the water cooling, water cooling, the pH in each soil. This isn't acidic or basic, so just using litmus paper. So it's acidic if it turns into red. It's basically blue, and it's neutral if it's stable in color.
What we're going to talk about. But this is the first time we're going to do one where I want them to design their own little experiment. So for water holding, the basic thing I have is they're going to put some filter paper in the funnel, some oil in there, measure out water in it, and like see how much of it is through, see how much it is through. They're going to come up with their own method.
Can you sit here for a bit?
Where am I sitting?
Right here.
I want to see.
Because I don't want them to sit. Thank you.
Not exactly.
I've been threatened, sorry.
You know?
Well, I shall be the piece.
I will be back.
You guys don't want to sit beside.
Doing the labs there.
Yep. Yep, I gotta go get some soil.
What?
Yes, everyone's gonna stay in their seats and we're gonna be shoved back. And then everyone else goes.
I don't know. What are fruit in the lab? I don't want to be fruited. Light your basement on fire. You got that? You know what? You're fine. I was more than you last time. Yeah. I don't know. We're doing lots of it. Yeah. Really small. I'm so confused.
Really small.
Probably be like
It's a
not answer 20 questions.
Well, surprisingly, it's very
I need a new kid. What's that?
Yeah, I'll just throw it up. I'll be walking.
Well, I have to do my slides.
I'm so tempted to throw my elbows.
Yes. Dude, my mom's dropping us off.
What I want to be for Halloween. Yeah.
I actually have the rusty one. Actually, the one it was white and black. So I just changed the white to the rusty. Yeah.
I hate
So that's kind of cool.
a man who had access to technology who lost the ability. Whale brew, is that a thing? Gotta read it. Add a few. Add a few.
I want to go.
What I did.
Just for safety. I got it. Be safe.
Am I the only one?
just want to be the spawn killing master though.
Oh, that was fun.
Dude, and then she rushed and she killed everyone. She had 12 kills. Oh, like that other guy, remember? Who killed him. Killed him. He had a London. Oh, I think he had a London. You don't even use these.
I don't have any money. Look at.
Yeah. Oh, yeah, and you're there.
I'm like, this is my
I'm
last.
okay with it. I want to get clips but actually, you spend it.
No.
What? That should be drop there.
Oh, yeah, just load up. Drop
I've never downloaded Flash.
Like my
I've never played. I knew that was probably going to rain. I'm just going to check it. What?
Where is it?
For a slice. Pull your hair. 485. It's for what do you do if I do that? Then I
I'm doing that now.
Yeah.
My reaction. No. You go quick. You gotta beat the clock. Yeah.
This is my third chapter. Probably like 3.
If you're not there, you're late.